Imagine a storm so violent it forces Greek sponge divers to shelter in a cliffside cove. The year is 1900. These men from Simi Island have no idea they're about to discover something impossible. Beneath them, 150 feet down, rests a Roman shipwreck. And inside, buried in the silt for 2,000 years, sits a shoebox-sized machine made of bronze, a device so sophisticated it shouldn't exist. 39 precision gear wheels, hand-cut with teeth finer than a millimeter, interconnected in ways that wouldn't be seen again for over a millennium. This is the Antikythera Mechanism, a hand-powered computer from 100 BCE that could predict eclipses decades in advance, track the movements of planets, and calculate astronomical positions with stunning accuracy. A technological marvel that vanished from human knowledge for 14 centuries. For 120 years, researchers have wrestled with its secrets. Who built this impossible machine? How did the ancient Greeks possess knowledge that disappeared until medieval cathedral clocks? And what other wonders might have been lost to time? This is the story of the world's first analog computer and the mystery of how it was created, forgotten, and rediscovered. The Aegean Sea in 1900 was treacherous. Greek sponge divers from the island of Simi had sailed to harvest the sea's bounty when a sudden storm forced them to seek shelter near the small island of Antikythera, halfway between Crete and mainland Greece. Elias Stadiatis, the lead diver, descended into the clear blue depths. What he saw would haunt him. At 150 feet below the surface, scattered across the seafloor, were human remains. Bodies. Dead naked people, as he would later describe them in terror. But these weren't recent victims, they were ancient, preserved by the cold, dark water for nearly 2,000 years. The divers had stumbled upon one of the greatest archaeological finds in history, a Roman-era shipwreck carrying Greek treasures from the 1st century BCE. The vessel had sunk sometime between 60 and 70 BCE, laden with bronze and marble statues destined for Rome's elite. Over the next year, Greek and Roman authorities organized a massive salvage operation. Divers in heavy copper helmets and canvas suits descended repeatedly to the wreck, hauling up incredible artifacts, bronze statues of young men, a philosopher's head, ornate glassware, and coins that helped date the disaster. But among the treasures, one object made no sense. It was a corroded lump of bronze, roughly the size of a shoebox, covered in calcified sediment and wood fragments. It had gears, metal teeth visible through the corrosion. The archaeologists catalogued it as an astronomical clock and set it aside, more interested in the beautiful statues. The fragments sat in the National Archaeological Museum in Athens for 50 years, largely ignored. It wasn't until 1951 that a British physicist named Derek John de Sola Price began examining the pieces with fresh eyes. What he discovered would challenge everything we thought we knew about ancient technology. This wasn't a clock. It was a computer. The Antikythera Mechanism, as it came to be known, is a masterpiece of ancient engineering. Originally housed in a wooden case approximately 32 centimeters tall and 17 centimeters wide, about the size of a large shoebox, the device contained at least 39 interlocking bronze gear wheels, each hand-cut with extraordinary precision. The largest gear measures about 14 centimeters in diameter and features 223 teeth. The smallest gears contain fewer than 20 teeth, some as fine as a single millimeter between cusps. These weren't crude castings, they were carefully machined components, fitted together with tolerances that speak to sophisticated manufacturing techniques. The front of the mechanism featured a large circular dial with 2 concentric rings. The outer ring displayed the 12 signs of the zodiac. The inner ring showed the Egyptian calendar's 365 days. 2 main pointers moved across these dials, one representing the sun, the other the moon. A small half-silvered ball rotated to show the moon's phases with remarkable accuracy. But the real complexity lies on the back. 2 spiral dials, each with multiple turns, track different astronomical cycles. The upper spiral, with 5 complete turns, followed the Metonic cycle 235 lunar months that synchronize with the solar year every 19 years. A subsidiary dial on this face tracked the 4-year cycle of Panhellenic Games, including the Olympics. The lower spiral, with 4 turns, displayed the Saros cycle 223 lunar months that predict when solar and lunar eclipses will occur. Small symbols marked specific months as likely eclipse windows, allowing the user to forecast these celestial events decades in advance. The gearing itself is extraordinary. The mechanism uses epicyclic systems, gears mounted on gears, to model the moon's variable motion as it speeds up and slows down in its orbit. A slot and pin mechanism translates this complex mathematics into the pointer's movement across the dial. This level of mechanical sophistication wouldn't be seen again in Europe until the medieval period, over 1,000 years later. Cathedral clocks in the 14th century finally approached similar complexity, but those were built with the accumulated knowledge of centuries. The Antikythera Mechanism appeared seemingly from nowhere, fully formed, as if its creator had access to knowledge that vanished with them. Today, only about 1/3 of the original mechanism survives 82 fragments of corroded bronze, their secrets slowly yielding to modern imaging technology. But even in its damaged state, the device reveals a level of astronomical understanding and mechanical skill that challenges our assumptions about the ancient world. To understand what the Antikythera Mechanism could do, we need to appreciate the astronomical knowledge embedded in its bronze gears. This wasn't merely a decorative device, it was a functional calculator that could predict celestial events with astonishing accuracy. The mechanism's primary function was to model the ancient Greek understanding of the cosmos. Turn the handle on the side, and the entire system came alive. The sun pointer advanced through the zodiac at a constant rate, completing 1 revolution per year. The moon pointer moved more complexly, accounting for its faster orbit and variable speed. But the device did more than display current positions. By rotating the handle to different dates, users could predict where celestial bodies would appear in the future or where they had been in the past. The gearing ratios encode precise astronomical periods derived from centuries of Babylonian observations. The Metonic cycle, tracked on the upper back dial, reconciles the lunar month with the solar year. 19 solar years almost exactly equal 235 lunar months, a pattern that allowed ancient calendars to stay synchronized with both the moon's phases and the seasons. The mechanism's 235-tooth gear directly implements this ratio. Even more impressive is the Saros cycle on the lower back dial. Every 223 lunar months, the sun, earth, and moon return to nearly identical geometric positions. This means eclipses repeat in predictable patterns, solar eclipses followed by lunar eclipses 14 days later, then a 6-month gap before the next cycle begins. The mechanism could forecast these events years in advance, marking likely eclipse months with specific symbols. Recent research has revealed even greater capabilities. In 2021, Tony Freeth and the UCL Antikythera research team published a groundbreaking reconstruction showing how the front display likely included pointers for all 5 planets known in antiquity: Mercury, Venus, Mars, Jupiter, and Saturn. Using epicyclic gearing similar to the moon mechanism, these planetary displays would have modeled each planet's complex retrograde motion as observed from Earth. This 2021 breakthrough solved one of the mechanism's longest-standing mysteries. For decades, researchers knew the front had additional gearing, but the specific function remained unclear. Freeth's team demonstrated that a complex system of coaxial tubes and nested gears could drive multiple planetary pointers from a single input, all while maintaining accurate period relationships. The implications are staggering. The creator of this device synthesized knowledge from multiple civilizations, Babylonian astronomical observations, mathematical techniques from Plato's Academy, and Greek engineering traditions into a single, functional model of the cosmos. It was, quite literally, a portable universe. In 2024, another breakthrough came from an unexpected source. Researchers at the University of Glasgow applied statistical modeling techniques originally developed for analyzing gravitational waves, ripples in spacetime caused by cosmic collisions, to the mechanism's fragmented calendar ring. By treating the surviving hole patterns as data points in a statistical distribution, they determined that the ring likely contained 354 holes, corresponding to a lunar calendar rather than the 365-day Egyptian solar calendar. This discovery resolved a long-standing debate about how the mechanism tracked time. It also demonstrated how modern cosmological research tools could illuminate ancient mysteries. The same mathematical frameworks that detect black hole mergers billions of light years away could decode a 2,000-year-old calendar. The Antikythera Mechanism represents humanity's first known attempt to model natural phenomena with mechanical means. It predates similar European technology by over a millennium, and it raises profound questions about what other knowledge might have been lost when this ship sank off the coast of a small Greek island. Despite over a century of research, fundamental questions about the Antikythera Mechanism remain unanswered. Who built this extraordinary device? How was such sophisticated technology lost for 14 centuries? The mechanism dates to approximately 100 BCE, though some scholars suggest a range between 150 and 100 BCE. This places its creation during a period of remarkable intellectual ferment in the Greek world, after the conquests of Alexander had spread Greek culture across the Mediterranean, but before Rome's complete dominance. Ancient texts provide tantalizing clues. Cicero, writing in the 1st century BCE, described mechanical devices created by Archimedes that modeled the movements of the sun, moon, and planets. He claimed that Archimedes even built a bronze sphere that replicated celestial motions. While the Antikythera Mechanism postdates Archimedes' death by several decades, it demonstrates that the tradition of mechanical astronomy he represented continued in the Greek world. Some researchers suggest Rhodes as a possible origin point given its astronomical tradition and the shipwreck's location along trade routes from the island. Others propose Corinth or Pergamon. The inscriptions on the device itself, thousands of tiny Greek characters describing its functions, use dialect forms that might eventually pinpoint its origin. But the deeper mystery is technological. How did knowledge of such sophisticated gearing disappear so completely? No other geared mechanisms of comparable complexity survive from antiquity. No texts describe how to build such devices. The technology seems to have existed in isolation, then vanished without trace until medieval European clockmakers independently developed similar techniques. This suggests either a lost tradition of mechanical engineering, far more advanced than we typically imagine, or that the Antikythera mechanism was itself unique, a singular creation of genius that never spread beyond its maker's workshop. Either possibility reshapes our understanding of the ancient world's technological capabilities. The Antikythera mechanism stands as a humbling reminder of how much we don't know about the past. For 120 years, this corroded bronze puzzle has challenged archaeologists, astronomers, and engineers to reconsider what the ancient Greeks were capable of achieving. Today, advanced imaging technologies continue revealing new details. Microfocus X-ray CT scanning has decoded inscriptions invisible to the naked eye, and statistical techniques from modern cosmology have unlocked calendar mysteries. Each breakthrough brings us closer to understanding how this impossible machine worked, yet the deeper questions persist. What other knowledge was lost when libraries burned and shipwrecks sank? How many other devices like this existed? And what might we discover tomorrow that rewrites history again? The Antikythera mechanism is more than an archaeological curiosity. It's proof that human ingenuity has always reached for the stars, and sometimes in ways we are only beginning to comprehend. The deep earth keeps its secrets, but slowly, piece by piece, we are learning to listen.